Today, we're going to talk about current trends in forensic science, and I'm going to start with a case study about Yara Gambirasio. So, in November 2010, a 13-year-old girl named Yara went missing after her gymnastics class in her hometown in Italy. Despite an extensive search, her body was not discovered until 3 months later out in a field. Investigators collected thousands of samples from the area, and a critical piece of evidence was a postage stamp. How did this postage stamp help? Well, the DNA uh, that was connected with the postage stamp actually led them to the killer. This case highlights the importance of forensic science in solving crimes, and it's an example of the power of DNA analysis in forensic investigations. So now I want to talk about types of examinations that are conducted by forensic scientists. The first is DNA profile extractions. So, forensic scientists extract DNA from various biological samples that are found at a crime scene. This could be blood, saliva, even hair follicles. And these profiles can then be compared to DNA databases. There are also testing of body fluids. This could be blood, semen, saliva. And again, these are helpful in solving crimes. Hair sample testing. So, hair analysis, you don't just remove DNA from hair, you can do other things as well. You can look at the color, the texture, the chemical composition. Fingerprint and footprint analysis, basically by comparing ridge patterns and various points on these, forensic scientists can determine if a particular fingerprint or footprint matches those at a crime scene. And then there's testing of weapons. So forensic scientists analyze weapons that are involved in crimes to gather evidence from fingerprints and DNA and gun residue and tool marks. Okay, so current and future trends in forensic science. There's DNA phenotyping. This is pretty cool. So DNA phenotyping is an emerging technique that focuses on creating visual images of suspects based on their genetic profiles. Basically, by analyzing genetic markers that are associated with physical traits, forensic scientists can generate approximations of a suspect's appearance. And this would include their eye color, their hair color, their facial features. And this technique holds great potential for narrowing down suspect lists and even generating leads in an investigation. There's 3D fingerprinting. Traditional ink-based fingerprinting is being replaced by 3D fingerprinting techniques that scan and create digital representations of fingerprints, and this method offers higher accuracy, faster processing, and easier storage than those ink-based methods. Then there's frontal x-rays. Frontal x-rays, specifically of the frontal sinus cavity, can assist forensic investigators in determining the age of juvenile remains. The development and fusion of the frontal sinus cavity continues until adulthood, making it a useful tool for the age estimation in cases involving child victims. Next, there's omnichrome photography. Omnichrome photography utilizes alternative light sources to detect bruising on the body before it becomes visible to the naked eye. By illuminating the skin with different wavelengths of light, forensic examiners can identify and document injuries that may have been missed during initial examinations. And this technique, again, can help provide critical evidence in a case. Then there's steam thermography. Steam thermography is a technique that employs a handheld steamer in combination with heat-related imaging to reveal even minute amounts of blood. By applying steam to surfaces, forensic investigators can visualize latent blood stains that aren't visible to the naked eye. And this method enhances the detection and collection of blood evidence, even when it's in concealed locations. There's video comparators. This allows forensic examiners to enhance and analyze video footage, specifically to identify and decipher writing on paper that might not be immediately visible upon inspection. And this technology assists in the examination of surveillance footage and handwritten documents. Last here, we've got bacterial oral decomposition. Forensic investigators can establish a more accurate time of death by analyzing the bacteria that are present in the mouth of a deceased individual. Bacterial oral decomposition provides insights into the post-mortem interval and helps investigators narrow down the time frame in which a crime may have occurred. I'll finish here by noting some issues and errors in forensic science. DNA testing has some limits. While DNA testing is a powerful tool, it's not without limitations. Contamination of samples at the crime scene or mishandling in the laboratory can compromise the integrity of DNA test results. Additionally, hair analysis has its limitations. Hair analysis is considered an inexact science due to difficulty linking to a specific individual. I'll say a little bit more about that in a future video. Then bite mark analysis. Bite mark analysis, the interpretation of bite marks as conclusive evidence has faced criticism due to the changing nature of bite marks as wounds heal over time. The characteristics of a bite mark can shift, making it really challenging to establish a definitive match to a specific individual. And there's actually a pretty famous case that came down to bite marks, or a critical piece of evidence in that case were bite marks that were left. And we'll talk about that case in the future. Last, I'll say here with fingerprint analysis, when only a partial fingerprint is available, that severely limits what kind of conclusions you can draw. It becomes difficult to make a conclusive determination with just a partial fingerprint. Forensic examiners rely on complete and clear fingerprints to try and establish a positive identification. So that sums up the some of the issues and errors that are in forensic science and gives you a sense of new technology that's developing.